Hi, welcome back to our second lecture for engineering statistics. I'm your lecturer. Last week, we learned about census, population, and sample. So census is all the member in a population, and I can give you an example. For example, all the UMS students. So the students in UMS are the census, each of you. Population is, for example, I would like to get some feedback from the FKJ students. So the light blue color is my sample. And yeah, that is the difference between census. Your question might be, can the light blue color also my census? Yes, because it represents the population. But I'm not only focused on the sample, which is light blue color. So we also learn about branches of statistics can be divided to descriptive statistics and inferential statistics. Descriptive statistic is something that you can collect, organize, summarize, and present the data. While inferential is, for example, you try to just ask few persons and get some feedback from the survey form. And you try to generalize that to represent as whole, which is not accurate. And we usually use prediction and estimation on this part. We're not going to focus on that. So descriptive statistics this is what we are focused on this part. Okay. So imagine we have some Lego that's a lot of children like it. So we have a bunch of data. We mix all the Lego together and we sort it out, which is collect the data, collect the Lego. We sort it out and that's called organizing, and we arrange it. By arrange it, we can see that which one have the highest color and which one has the lower among them. So, and then we try to summarize it and we present the data as explained with a story. Like you can use that, among all the data, I have the highest in blue, and I can further explain that and become a story. Can you imagine that? That's what about statistics about. So this is some of the example to differentiate descriptive and inferential. Right, let's have a look on some of the example how to differentiate between the inferential and descriptive. Is quite when you look at the sentence, question number 2 is about predicts, means that they don't have the strong figure data to represent the things. So that is inferential. And number 3 is it seems like it's claimed that it's proven, but in actual it's not, that is inferential. Can you see the danger on inferential? So that is not really represent the actual performance. So today we are going to focus on type of data, how to collect the data and summarize the data. So there are 2 types of data, qualitative and quantitative. So qualitative is something that, for example, temperature, length, some of like ratio. If you do the ratio, you don't have unit. But actually, that is quantitative. For inferential, in interval, you have the range. Okay, for example, from 12 to 1. Temperature, the human temperature, 36.7 until 40. So when you have high fever, all right, so that's quantitative. So qualitative can be divided to ordinal data and nominal data. So ordinal data that you still can convert it into some useful data. Well, nominal data, you can't rank them, okay? So for example, in the ordinal data is, for example, degree of satisfaction in restaurant. You can give 1 to 10. 10 is the best, the thing is the fantastic taste. 0 is poor, the hygiene, and the taste is tasteless. Nominal is male and female. How can you rank them, which one first? So those are nominal, okay? Yeah, this is some of the example on the nominal and ordinal, right? And I have also given some of the example. For example, number 2, So the student that respects spectacle, so you can't rank that. So that is definitely nominal. Ordinal, for example, satisfaction on this subject. So you very understand or you hardly understand. You still can make it a level, right? So next we move to collecting data. How the data is collected. So like I mentioned to you, before you do the sampling, you have to make sure your population is large enough. You have the specific data on that one. And how was the sample selected? That is very important, right? So there are the general field sampling techniques. Simple random sample is quite often like lucky draw. You have a bunch of the voucher and then you just put in your hand, randomly pick it. Or you can use Excel to do, for example, in this example, I try to randomly select 1 to 10 balls between them. You just select them. Okay. Systematic random sample is like, for example, quite often like the 5th call to the radio will selected to join the competition. Yeah, that's the simple example. For example, there's a bunch of the hard disks and the 5th hard disk will select to do the testing to check the reliability. Or the third one is stratified random sample and cluster random sample. They are quite confusing, I would say, but I think let me show you a picture that will be easier. So stratified random sampling, I divided to 2 subgroups. So in this case, I divided to a male and female. From there, then only I randomly select them. For cluster sampling is I divided to maybe 3 in each group. Doesn't matter, it really doesn't matter male or female. Then I just randomly choose among them, right? So that is a difference between stratified random sampling and cluster random sampling. Is that clear? So random number table, before we have the Excel, we also have you can use the, this is one of the example of random number table. Like I mentioned to you, you can use Excel or you can try to Google how to use the Excel to do the random sampling. In this case, we are trying to select a few school to join the competition or survey, so they use the random sampling, right? So in this case, for example, the big N is I have 517 schools, and I would like to divide the class into 30. So, and then I divided them to 30, I have 17.233. And therefore, every 17.3, or I round it up to 18, will be selected. So it still depends on, how to say that, which one you want to start first. So first I do the random, use this code random, and I use this code random, and I can see that 2.9 and rounding up number 3 will be the first one. Then after that, from there, every 17, okay, every 18 will be the next candidate selected. Try this in Excel and let me know, do you manage to do that, okay? So organize data. Once we have, we know the different way to sampling. So we organize the data. Okay, we organize the data like I mentioned to you just now. We sampling and then we organize it. Okay. So for qualitative, okay, qualitative, for example, I have 25 students and I still can convert it into some table form. I divided to 2 subgroups. It's quite easy, female and male. And I count them. and I convert them into a frequency table. That is the simplest one. Well, what about I have more than 25 students? I can't just do that. I can also convert into classes, frequency distribution graph. So in this case, for example, compression strength of 100 aluminum lithium alloy specimen. So I can convert it into some class. So first I choose the lowest and I choose the highest. And then I have to follow the rules for the distribution frequency. Okay. So let's say there should be between 5 to 20 classes. It's preferable to have odd number. So this is easier for everyone. Okay. Odd number. And the class must be mutually exclusive, no overlapping. For example, 1 to 20, and then you start with 20 to 30. So when you have a number of 20, they will be confused. So we don't want that overlap. The class must continue means 1 to 10, but you don't have any number from 11 to 19, for example, 11 to 20. You still have to put the class there. Okay. So the class must be equal in width. So you can't just, for example, the class is 1 to 10, another one is 11 to 15. You have to have a proper width. Okay. So class is, we talk about a lot of class. What is class means? Category of grouping data. So for example, so I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 classes here. All right. So these are called class. Class mark and midpoint. Class mark and midpoint in this case is a single value used to represent the class. So how to get the class midpoint? We've tried to find the upper level limit and the lower limit divided by 2. That's your midpoint. The frequency is the number of serves found in a class. So from there, so from there you know how many in that class. So I give you an example for the this set of data. So just now we know that the highest is 249 minus 100, that is the range. So we try to find the range first. And then I decided that I think I want to convert this into 8 range. So which is in between 5 to 20 classes, okay. And then I divided to 8 and I get 18.6. So I round it up into 19. So 100 to 119. Okay, so then I count it and I convert the class mark. I mentioned to you that the class mark is lower limit, upper limit over by 2. It's quite straightforward. Then I convert into frequency, and then relative frequency is actually I convert everything into 1. So it just, The cumulative is you just keep on adding, and that at the end, that is the total of the sample. Cumulative relative frequency is actually I convert it into 1. That is the difference between them. So you understand on this? Once we have the table, what else? We can convert this data table into graphical form. So like qualitative data, we can convert into bar chart, pie chart, or we can convert the quantitative data into dot plot, stem, leaf, diagram, histogram, density, histogram, polygon. Box plot. Another one is box plot that we are going to learn this one. Based on the survey, most of you already know histogram, already know some of the general chart that I'm not going to touch much on this. This is the example for the qualitative data. Okay, so different brands, different factor, and I can look at the number of defect. And this is the pie chart for the qualitative data. So we can also convert it into histogram or bar chart, bar graph. So for the quantitative, we can convert into polygon or GIF. If you look at this, ORGIF is a cumulative frequency. For polygon is we are trying to look at the frequency. And this time, in this part, polygon, we are trying to use the midpoint. Yeah, the midpoint that we learned just now. Okay. And another one that I would like to introduce to you is Boxplot. Probably is a bit new for all of you. Boxplot is, if you look at it, it's quite similar to the bar, okay? But it's actually not. The difference is the bar is, this is the standard deviation. Whereas for the box plot, we have the quartile, first quartile. We have the third quartile. This is the IR. If you look at this, this is the the dot is the outer outlier, and at this point is the maximum. Okay, and from the upper quartile to the maximum is about 1.5 IQR, and from upper layer, upper quartile to lower quartile, the whole thing is 1 IQR. So your maximum value, okay, it's about 1.5 IQR. Okay, IQR between for those that above that, we consider your data is at outlier. For this one, the lower quartile to the minimum, okay, if your sample is within 1.5 IQR, that is including in the, how to say that, in the minimum. Above, out of the 1.5, we will consider that as outlier. See that? Let me adjust a little bit. Okay, on this. It sounds a bit confusing, isn't it? So let me check on this. How to do this? Okay. So I repeat again, a box plot is to try to convert all the data into the maximum, the upper quartile, the median, the lower quartile, the minimum, and how to find the outlier. As long as from the lower quartile to the minimum, it should be within the range of 1.5 inter-quartile range. Those data that outside of 1.5 IQR inter-quartile range, we are considered as outlier. Are you clear now? So first, what should we do here is, what can you do first is, you try to find the median. So in this example, I try to find the median. So median is different compared to mean. You have to be aware of that part. Okay. So the median split the data set into two equal groups. All right. So you find the median first, and then you split them into another half. Okay. It will be about 25%. So, and the other side, another half. So the 125 in this part, in this case, is the first quartile, lower quartile. And the 260 is the higher upper quartile. So this one, the 195, in this case is the median. Median and mean is different, yeah? Okay, so once you have it, and then you look at the minimum. In this case, 45 is the minimum, and 380 is the maximum. Okay, so now we are ready to draw the box plot. This is the simplest one. So I have the lower quartile, 1 to 5. I have the median. I have the upper quartile. I have the maximum and the minimum. And then I draw the range out. I draw the range out. Okay? But be aware on, if you look at the box plot, is very interesting. Each box plot, they have different scale. Okay, you have different scale. So you have to be careful on that one. So for example, the top one and the lower in this case, they are actually have, from the first one, it start from -10. For the second one, is actually start with 1. So you can't compare them directly. You have to analyze it properly. By model. When the data is distributed into by model, rather than the one lump versus the box plot will not give you any evidence of this. So if you look at this one, even though you have a lot of the data in the upper quartile, you can't just show, you just can't show the distribution on this part. Okay, overlapping. So in this case, the lower quartile and the median overlap. So what does that mean? It can happen, yeah? The median and the lower quartile are overlapping. So it means that 25% of the value are the same between the lower quartile and the median. That could happen. The minimum and the lower quartile are overlapping. This is occur when 20% of the value are same between the minimum and the lower quartile. So when your sample 25% between minimum and lower quartile, you don't have the whiskers for the lower part. You still have the whiskers if you have your median same with the lower quartile. Understand, right? Okay. And some of you might be confused with this with the arrow bar. It's actually different. It's not the same. Box plot for the candlestick, they are different. They don't have the horizontal stroke. They don't have the outlier, right? They also not the same with the error bar chart. This is represent the standard deviation. It's totally different compared to the box plot. Okay, so be aware on that part. Okay, so all right. Now let's have a look on this example. This is some of the data from the journal, the latest journal. So for the picture figure 4B and C, as you can see that, you can see a lot of box plot. Why I know this is box plot? Because you have the whiskers, you have the box there. Without the whiskers and the horizontal stroke, that's not. Okay, in this part, yes, they are. And they try to adjust it into a same unit. Okay, so in this graph, there are a lot of information we can extract from them. For example, what is the median of ultimate strength of the sample of RG, 1% of weight, DOPA, CAT 2 positive with 25% of band if you look at this, there are a lot of box plot, but 20, this is 10, 25 is here, and I'm looking at this one, /cat. So I'm looking for the red color. This is the sample that I'm looking at. So the question asked is ultimate strength. So we are looking at the B because the C is the modulus, Young modulus. Okay, is that clear? Okay, since we are looking at this, the red color on this part, what is the median? Then you look at the y-axis, it's about 1 to 5. Okay. Question number 2, what is the difference between range and IQR of the sample at sample 1? What is the range? So the range is the maximum and the minimum. Remember, range is the maximum and the minimum. The interquartile range is the upper limit and the lower limit. The upper limit, okay, and the lower limit. Okay. So from there, you can get your IQR. Range is for the maximum minus the minimum. What is the percentage of sample 1 that at least 150 megapascal ultimate tensile strength? What is the percentage sample that located at the 150 megapascal ultimate strength? So I will say in this part, you are actually, I will say this is because this is upper limit. So upper limit is about 25%. Can you determine if any sample with ultimate strength of 145? So is there any sample here? No, I can't. Right, I can't. What is the percentage were between 125 to 150? So 125, if you look at it, 125, it seems like the lower limit, a lower upper limit. 150, then I look at the 150. Okay, the 150, it seems like the upper limit. 125 is about my median. So my median to the 150, what is that? So it is between upper limit and the median. So that is another 25%. Is that clear? Okay. Shall we move? Is that okay to move to another stage? Okay, next we go to discrete data with numerical measure. Now, just now that I show you how to do the box plot. And actually, we can further analyze our data into three levels. The first one is measure of central tendency, which is very common for us, how to find the mean, average, or in other words, median in the middle among all the sample. You arrange from the lowest to the highest, and then you find the middle. That's median. Mode is the highest among them. So for example, I have a bunch of number 1, 2, 2, 2, 2, 3, 4. So 2 is the mode. So measures of dispersion, we can measure to know how the data disperse around the mean. So are the data spread evenly or they lump together in one side? So we can get the range. The range is the maximum value minus the minimum value. Variance and standard deviation, that is quite common, okay? And measure of the position. So measure of the position is measure the position of determine a specific data value fall within the data set or relative position in comparison with within the data value. So what is that means is actually what that means is imagine you have a lot of data, 1,000, 100,000 of data. I would like to know that one of the sample inside the data, where is it located? Is it within the range? Like just now we learned about quartile. Is it within the first quartile? Is it within the percentile? Or is that outlier? Is out of our range? We should just remove it, because if we involve it, it will affect the whole it can affect our the whole thing, right? So we can adjust our data based on that. So by looking at measure of sample tendency, like I mentioned to you, mean is the sum value over the number of value. In other words, it's the average. Median is the middle value in order list. Mode, most of the frequency value, mid-range. Mode is the most frequency value that I mentioned to you. Mid-range is the middle of range. So for example, this is the bunch of the number. My mid-range is I find the maximum and I find the minimum and I divide it by 2. That's mid-range, or we call it as range, right? So you can try in the 3 minutes workout on this part. As you can see, number 3, so we can't get the mean, we can't get the mean range because this is qualitative data. But for the quantitative data, for the example 1 and 2, we can find them for the mean, mode, median, and mid-range. Okay. You might say, why we need the mean? Why we need the mode? Why we need the median? If a small set of data, it's quite easy for us to find the median, quite easy for us to find the mode. But imagine we have a large data, so that might give a good value and meaning things for us. Measure of dispersion. Like I mentioned to you, range is maximum minus the minimum. Variance, the mean of square deviation. So what is deviation? What is the difference between deviation and error? So this is some of the questions that you might ask. Standard deviation is the square root of variance. Interquartile range, just now we learned about interquartile range, right? IQR. So we try to find the upper limit minus the lower limit. Like I will mention just now. It sounds quite confusing just now without explaining what is quartile, isn't it? So basically, we divided each of them for the maximum. To the upper quartile is 25%, upper to the median 25%, median and lower 25%, lower to minimum 25%. Basically, we divided them into 4 parts. So that is quartile. Okay, so the interquartile range is if you look at a box plot, the upper quartile minus the lower quartile. So 1 IQR is about 20% or on the sample, which is within the upper quartile and lower quartile. Okay? Okay, so is that understand? Do you understand? So why we need that? Because for example, by looking at the mean, median, mode, if they are at the same value, we know that the sample is quite symmetric. But if our mode, median, mean is slightly moving, not the same value, by looking at that, we roughly can estimate that our data is more to right skew or left skew. Okay, so that is the quick way for us to analyze our data. Okay. Another one is standard deviation. So imagine that this is the mean. This is our mean. Okay. So this is our value. By looking at the deviation, we know that how much error for our value, actual value, to the sample selected. And we can know further information from that. So how to find that? So we will look at the next stage. So variance, I think you learned this in your matrix in your Form 6 STM and diploma. I'm not sure about diploma, but yeah. So calculate the mean first. This is a variant equation, quite simple actually. So first you find the mean first, then you make a table like this, okay? So your value minus the mean and square root it. Why we need it? Because this is the sum. This means it's the sum, okay? So you have to, by making this table, it's easier for you to get the sum of this. And if your sample is small, you have to 1 over number of sample minus 1. Whereas for standard deviation, you just square root it, you can get a standard deviation. In this sample, okay, I have 8 data. I total up them and divided by 8. So that is our mean. So then we further analyze it, put the value in, we can get our variance and we can get our standard deviation. Okay, so for the deviation, okay, for the deviation, if you sum up this, it's always equals to 0. Okay, which is correct for the first one. The variance is small, so means that you have little variability in data. Whereas for variance is large, the variability is large. So your sample is very spread around. Okay, so the variance and standard deviation describe how spread out the data is. If the data lies close to that data, then your standard deviation is very small. Okay, if your data stick together close to data, your standard deviation is very small. If your sample is spread very far away, so you even have the outlier, then your standard deviation will be very large. So probably you can just remove the outlier so that you can just focus on the sample that you're looking at. Yeah. So next, you can try on this, calculate the sample variance and standard deviation of this sample. It's quite straightforward. First, we find the mean, and then after that, we minus each of the data minus the mean. How do we know whether it's correct? You just sum up together. You should get a 0 here. Means you are good to go. And then use times power of 2, and you can get the total. Plug it into the sample, get the formula, and you can get a sample variance. Sample deviation, standard deviation is square rooted. So you can have your standard deviation is about 17. It's quite straightforward, isn't it? So for the measure of position, there are 3 things you can learn: quartile, percentile, there's Decile. Quartile is we have a bunch of data, we sort it out, order it in the order, lowest to largest, and then we divide it to 4 equal parts. So if you look at this part, okay, so I try to draw the line here at the bottom, okay, can you look at this part? So I can divide it to 4. So this is the first quartile. First, I find the second quartile first because that's half. From the half, I find the another half. So it will be easier for you. Percentile is to divide it into 100 square parts. So for example, if you want to have the 10 percentile, you just plug in 10 here over 100, but you need to plus 1 for your sample size. For example, you have 12. then you have to plus 1 to find your 10 percentile. That's Decile, you divide it into 10 equal parts. So 10 equal parts is quite similar to the percentile, but you divide it into 10 equal parts. So this is the example. I arrange them first, and then I divided to find the median. Okay, so the median is 11. And then from here, I divided to 2 again. So my Q1 is the 8. Q1 also equals 25th percentile. And then from there, I find my Q3. Okay, so then I check 25th percentile. So I try to, in this part, I try to put it 25 because I'm looking at 25 percentile. And I have 11 sample. So I have to add 1. So it becomes 12. And sort it out, the third one is my first quartile or 25th percentile. What about Q2? We can check Q2 is the 50 percentile. Okay. And we try to put in the value. Yes, our second quartile, the median is 11. So next lecture, I will teach you about Z-score. That is very important for you to further analyze at our stage number 3, which is measure of precision. From there, you can find the percentile. We learn about percentile, quartile. Outlining is something that outside of it. Z-score will involve a lot of rules. So I will give you more example next lecture. So see you guys for the face-to-face lecture next Monday.